Okay, because quite frankly, I'm quite tired of getting this question in class. The question is water wet? So first, we have to define two things. What is water and what is wet? If we look at the chemical definition of water, that is simply H2O. Two hydrogens, one oxygen that are bonded roughly like that. So you have a little H here, and you have a little H here, have an O here. Kind of looks like Mickey Mouse. And then we have what is wet. Well, according to the dictionary, if you type in define wet onto Google, you end up with covered or saturated with water or another liquid, or you have to cover or touch with a liquid to moisten. So the first one's an adjective, the next one's a verb, and then you have a noun that's liquid that makes something damp. So I'm just going to go with the first one is water wet. So covered or saturated with liquid or another liquid. With water so wet. Wet, adjective, covered or saturated with water or another liquid. So allow me to go through a train of logic with you. First, imagine you have a ball. And imagine that the ball is covered or surrounded by water. Let's say that each of these represents a little water molecule. In fact, I'll even go the extra yard and cover them in blue. So you can kind of see that this is supposed to be a water molecule, a molecule of H2O. You would say that this ball, because it is covered in water, would be wet, right? Yeah, of course. That's the definition of wet, covered with water. So let's make the ball smaller. And let's cover that one with water. So now we went from what would this be? Like a beach ball to a tennis ball. So if you cover the tennis ball in water, cover it with water, then is the tennis ball wet? Well, yeah, it's covered with water. Therefore, according to our definition, it is covered with water, so therefore that tennis ball is wet. Okay, let's take it. There are two more steps to this logic. Let's make it one molecule big. So this is supposed to be that we have a ball that's made of one molecule. One molecule big. Well, let's cover that with dihydrogen monoxide, H2O. Let's cover it with water. Would that molecule be wet? Well, yeah, if that is wet and that is wet, then therefore that is wet too, because it is covered or saturated with water or another liquid. So this gets at our final point. What if instead of a ball, it was, or a one molecule big ball, it was one molecule big of water? And then you surrounded that molecule with other dihydrogen monoxide molecules, other H2O. Well, we would therefore say that single molecule of water is wet because it is surrounded by water. It is surrounded by H2O. And if you line up more, then look, if you put them all together like in a drop of water, and there are a billion trillion water molecules in a drop of water, then this one is, if this one is surrounded by water molecules and that one's wet, well, look, this one is too, because it's surrounded by other water molecules, therefore it's wet. This one is surrounded by other water molecules, therefore it's wet. Look, you see a pattern emerging that because each water molecule is itself surrounded by other water molecules, then every water molecule is wet. It is covered in some way. So, therefore, water, which is H2O, is wet because each molecule of H2O is surrounded by other molecules of H2O as well. Water is wet. Don't take any more than my class time in order to answer this, okay?